Alright, we're going to spend a little bit of time today talking about some word problems with our quadratics in standard form. So the first one is, a rocket is launched on Earth from a platform 5 meters above the ground. Alright, the rocket has an initial velocity of 50 meters per second. The equation modeling the flight of the rocket is as such. This is the equation right there. Alright, so the first question is, what are the x-intercepts of the equation? So I want you to go ahead, take a pause on the video, and plug this equation into your calculator and find what those x-intercepts are. Now, when we go to our graphing calculator, if I go here to Desmos, let's look at those x-intercepts. I'm going to be at, we've got an x-intercept at negative 0.99999. We're going to say negative 0. Or negative 0.1, all right, just to round it up, and 10.303, okay? So negative 0.1, oops, x equals negative 0.1, and x equals 10.303. So what do the x-intercepts mean in the context of the rocket flight? So it really doesn't make sense to have a negative time, and notice that's because we didn't start. It said it started 5 meters above the ground, right? And if you look at this, I have a y-intercept at 5 meters above the ground because that's where time 0 is. Time 0 is up there. It's not down here. So really the only thing it tells us is that at 10.303 seconds, the rocket hits the ground. All right. So over here, right at 10.303 seconds, right there, the rocket hits the ground. All before that, it's flying in the air. All right. So what is the vertex of your equation? Let's go look at that. So vertex of the parabola, which is a maximum here, right? Because it makes sense for the rocket to go up and have a maximum. It's 5.102 and 132.551. So we've got 5.102 and 132.551. All right. What does the vertex mean in the context of the rocket flight? Well, let's look at this. X, in this case, is our t, correct? And t is time. So that means at 5.102 seconds, the rocket reaches, now what was the y value? Y value is h, which is height. So the rocket reaches its maximum height of 132.551. What was our, oh, we were working in meters. All right, meters. Cool. So you'll see that that equation actually allows us to know a lot about the rocket, right? We get up to 132.551 meters at 5.102 seconds. That will be when the maximum occurs, right? We also know we get down to ground zero, that we get back down to zero height at 10.303 seconds, okay? All right, let's go ahead and try one more together. So this second one, a stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second, at an angle of 30 degrees from the horizontal. So let's draw a picture here. We've got a cliff, all right? The stone is thrown off, woo, and goes down, okay? This is the stone, something like that. And this stone is thrown from a 100-meter cliff. So this is 100 meters right here. So notice there will be an x-intercept down here, right? But that's not going to make sense. We only are going to care about this x-intercept, right? The horizontal, when it talks about that, is talking about right here, okay? That's all it's talking about. So the height of the stone can be modeled by this equation. Let's go ahead and plug that into a calculator. Go ahead and pause the video, plug it into the calculator, see what you get. See if you can figure out when will the stone reach its maximum height. All right, so we should find its maximum height right there, right? And we know that this is going to have an x and a y value, which really is the same thing as a t and an h value. t being time. So whatever our x value is, that's going of the maximum, that's going to be the time that the stone will reach its maximum height, the when. So let's go ahead and look at our graph. I have this graph set up over here. Let me make sure that's the right one. Yep, that's the right one. Okay, we're good. So I've got this graph set up over here. If we look at that maximum, notice it starts at 100 meters. Look at that. Goes up, 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 reaches the maximum, 1.02 and 105.102. So I'm going to erase these. We get 1.02 and I do not remember. I think it was 105.102. Yep. 105.102. So when will the stone reach its maximum height? At 1.02 seconds. All right. What is the maximum height? Well, we've got it right there. 105.102. And this problem is measuring in meters. So that is meters high. When will the stone hit the ground? Well, where along this parabola is the stone hitting the ground? That's right over here. This is where the stone will hit the ground. So let's go look at our x-intercept. If I look down here at my x-intercept of my graph, right there, 5.652, it will be at height 0. So this is 5.652, height 0. So at 5.652 seconds after it is thrown.